Can we talk about it, guys? Can we talk about it? It's been in my mind lately. The concept of space and time. Can we have an honest discussion about it? Right? Can you and I have an honest discussion about what is space and time? So I'm gonna draw something for us real fast, right? I'm being honest, right, when I draw this. So let's just draw a quick graph. And let's call the vertical axis time. Let's call the horizontal axis space. Right? Easy enough so far. Great conversation, right? And let's say we say something happened, right? Something physical happened at, who cares, right? We're not gonna get too deep into the labels. That'll be for future videos. But for now, let's just say something happens here, right? And then maybe 5 minutes in the future, we go up here, right? So what this tells you is this thing happened at this position at some time. This mark up here says same position, but different time. Is that possible, right? And let's add another event at a different position, right? So let's say it happens over here at this position. Something real happened. And let's mark it up here. So what this diagram is showing us so far, right, is that these right here, actually let me get another marker here real fast, right? This right here, that tells you same position, but different times, right? And then this one right here, same time, but just two different positions. Does that make sense? Does our universe obey rules like that, right? Like, ask yourself, like you might be thinking to yourself right at home right now, this is intuitive. This is the universe, right? And you're sitting at the chair at home watching this video right now. You're like, hey man, that's me. Same position, but different time. And so we gotta pause for a second, right? Because while that picture makes intuitive sense, would I measure your position to be the same? Right, you gotta ask yourself that. Would I measure your position to be the same that you're measuring? Would my picture of you on your chair be the same? And you think to yourself, well, probably not, right? Probably not. I would never measure you in your chair to be here. Because your position is different from my point of view. But not only from my point of view, what if I asked my friend on Pluto to measure where you were at? His would also be different, right? His would also be different. And so this concept's kind of getting muddy now, right? Right? Can we ever say something has the same position at different times? The answer is no. Right? The answer is actually no. Not that shocking though, right? You kind of just say, okay, cool, that makes kind of sense, right? Things have different positions depending on who's asking them. And bingo. Bingo. That's the physical concept. People have different positions, or events have different positions depending on asking. And we go a little bit further than that, right? We go a little bit further than that. I will give it to you in fancy languages real fast. I will give it to you in fancy language. The actual physical principle we're talking about right now. The physical principle we're talking about right now is that you cannot mechanically differentiate between something called uniform rectilinear motion and stasis. Fancy, right? That's a lot of fancy words I just threw at you. But what I just told you makes so much sense once I break it down for you. All that concept is you can't actually tell the difference between constant velocity or constant speed and being at rest. And that might blow your mind for a second. It truly might blow your mind for a second. But I want you to ask yourself, close your mind, put yourself on a train real fast. When you're inside that train, you don't look outside. Do you feel yourself moving? Do you feel the earth moving around the sun right now? Right? That's the physical principle we're talking about. So if you can't measure through experiment constant velocity versus being at rest, you soon find out that same position isn't a really universal concept, right? Because it depends on who you're asking to. Who's asking the question, right? Because if you look around the universe around us, the universe is in constant motion, right? And so you may feel like this makes sense, but in reality, it does not. There is no such thing as absolute position. And it makes sense, right? Position and velocity only make sense when you define a reference point. With reference to what? And so, now let me get my eraser here real fast. We kind of have to change this, right? We kind of have to change this. So let's update our view here real fast, right? Because we hit our head on the physical principle. So let's say this is you in your chair. And I ask someone else, let's say from Pluto, I say, hey man, where am I at in your reference system? Say, you're over here, buddy. Right? You're over here. And then I ask some guy in Andromeda Galaxy, hey man, like where am I? Well, this thing happened. Where did you measure it? You say, hey man, I actually measured it over here. Right? Makes sense, right? How we measure position is all relative to something else, right? So if I'm in the Andromeda Galaxy, of course, I'm just gonna measure you and your chair different, right? If I'm on Pluto, I'm gonna measure you and your chair different, right? How you look is gonna look different in my reference system. Makes sense, right? This concept is known as Galilean relativity, right? And so physicists had to stop and kind of ponder that for a second, and we figured it out, right? We can actually talk about these different reference systems and how we can talk about like how can I, if I'm on Pluto, how will I measure, the events you're talking about, right? We can do that. It's with math, right? Simple transformation. And so let's summarize the video here real fast. What did we learn today? We learned today that it makes no sense to talk about position unless you put it with reference to something, right? The same position means something different if I'm talking about from the point of view of Earth, from the point of view of my friend on Pluto, from the point of view of my friend on the Andromeda Galaxy, and the point of view of the sun, right? Makes sense. But now we have another conundrum. What about this? Does this make sense now? And I truly want you to wonder that. We just made the claim that at the same position but different times doesn't really make sense, because the same position with respect to who? Who what position? Let's flip it on its head. Let's flip it on its head real fast. Does different positions at the same time make any sense? I want you to ponder that. And I want you to write to yourself. I want you to write an answer to yourself. And let's address it. I'll address it in the next video. But truly ponder it.